Good morning. Assalamualaikum, everyone.
Selamat datang.
I think we should wait for a few more minutes, let other students to come in. In the meantime, please write your name in the and matrix number. Six students. Okay, I think we can start and then let the other students to come in. Okay, we left last week. We left at the business process management. One of the tasks that have been used by that commonly being used by the data warehouse is measuring business performance, which is part of business process management. I'll share my screen. We continue with uh, the topic two first. Okay, we covered business process management. Okay. Okay, business process management is a real-time system actually that alerts managers on what are the potential opportunities, uh, problem and threats, and so that they can react through models and collaboration. So there are several terms that are being used by different actually vendors or consultants in this area. Some call it corporate performance management, some call it enterprise performance management, strategic enterprise management. But for the book that we use as our textbook, they we refer to it as business performance management. So it's general, and then we not um, specify to any particular vendor. So the business process management actually refers to the business process, methodologies, metrics, and metrics meaning that how do you measure, and then technologies used by enterprises to measure, monitor, and manage the business performance. So there are three components, which one is the set of integrated closed loop. It is a closed loop. This is what it means by closed loop. Uh, a set of integrated closed loop. So and then analytic process supported by technology, and then they have tools for the businesses to define their strategic goals and then measure and manage performance against them, and then method and tools for monitoring key performance or KPI linked to the operational strategy. So we have there are four components: strategize, plan, monitor, and analyze, act, and adjust with its own sub processes. So first we look into the first one, which is the strategic strategize. Strategize comprise of this mission, values, goals, objectives, incentive, and strategy maps. So this strategize is where do we want to go. It is strategic planning. Common task for the strategic planning process is to conduct the situation, the current analysis, the current situation analysis, determine where do you want to go, meaning that you look into the planning horizon, conduct an environment scanning, and then identify your critical success factors. Then you, from the present situation and your horizon, you do a gap analysis. And then you create a strategic vision so that you develop a business strategy. And then you identify the strategic objectives and goals for your organization. Uh, okay, in my notes, uh, I, in my open learning notes, in my open learning notes. Okay, these are my yeah, so it is normally planned by created by a team of corporate executive approved and authorized by the board of directors and then implemented by the company's management team under the supervision of senior executives. So it provides overall direction to the enterprise. Yeah. So the next one is planning. Where do we get there? How do we get there? So first we want where do we want to go, and then how do we get there? Planning. It comprises of budget, plans, forecasts, models, initiatives, and target. There are two types of planning: operational planning and financial planning. Two types: operational planning and financial planning. So the operational planning is to translate the organization's strategic objectives that they have been determined during the stage one, and then translate them into the strategic objectives and goals into a set of well-defined tactics and initiatives. So when you remember the we covered in our MIS topic, I think. At the top is strategic level, in the middle is what we call tactical level. need to translate what is in the top level towards the middle level management. So a set of well-defined tactics and initiatives, maybe meaning that you have your tactic for marketing, your tactics for production, and then costing, and so on. So a set of well-defined tactics. It is based on the function or operational. So, and then what are your resource requirements? What do you need to implement the your operational planning? And then what is the expected results for some future time period? So usually a year. So commonly the strategic planning you will go more than 1 year, maybe 3 to 5 years. But for operational planning, it is year by year. So there are two types of, okay, here I do not detail the financial planning, but it is in my notes. Uh, there are two types. The financial planning and budgeting process has a logical structure, and that starts with the tactics, how to generate revenue or income, and then it needs to be collaborative within the other and then dependencies within the functions, meaning that you have finance department, you have production department, you have sales department, so each of it must be collaborative. So, and then besides this collaborative input, the organization also need to add some various overhead costs and cost of capital. Overhead cost is normally when you look into cost components, we have this variable cost and the administration or overhead cost, a general cost. So the cost, so the function, the tactical level functional financial planning usually you begin at the variable cost, and then there are these admin costs or general costs that we refer to as overhead costs. And then besides the operational costs, most of these overhead and the functional costs are variable costs. We also have cost of capital, or sometimes we refer to as capex, capital expenditure. Yeah. So this consolidated information will show the cost by tactics and cash and funding requirements to put the plans into operation. So this operational planning need to tie up with the financial planning and budgeting process. So when you run your operational planning, there is related financial planning and budgeting processes. Yeah. Okay. If there is any question, just ask me. I need to move back to the other page. Okay. So there are two types of operational planning, which are actually it's financial planning, budget centric financial planning. Okay, and then the third step is to see that how to monitor our performance. We have performance dashboard. This is part of your assignment, performance dashboard reports and analytical tools. How do you monitor and analyze? So it is a comprehensive framework for monitoring performance. It look into two key issues: what to monitor, your critical success factor, strategic goals and target, and how to monitor. So let me see what is in the okay. So we look into what to monitor and how to monitor. So as it would be impossible for the organization to look at everything, it needs to focus on monitoring specific issues. So you need to identify the indicators and measures to what measures you need to look at. Develop a strategy for monitoring these indicators and be able to respond to them effectively. So these indicators are measures are most commonly referred to as key performance indicators. So in your group assignment, you are supposed to build a dashboard, and then this dashboard should have this monitoring measurement. How do you, and then you look into what you cannot be monitoring everything, but it has been spelled out in the task actually. So you need to identify what monitoring, what sort of what KPI, what sort of performance KPI that you want to monitor, that need to be monitored for because in your assignment there are two levels. One is for the COO, the other one is for the human resource. Yeah? There are two types. Yeah? So that is the first part is the act and adjust. How do we need to do? What do we need to do differently? After your monitoring, you need to look into what do you need to. Uh, how do you improve actually? How do you act and adjust? Yeah, what do we need to do differently? So usually when you it goes back to the new projects. You will create new products. You will enter new market. You will acquire new customers. Streamline some processes. So some or most of these some of these projects might fail. So what are the chances of failure? So let's see in your planning. Yeah. So you read your open learning. Open learning is quite detailed. So you need to take corrective action. Yeah, you need to take corrective action so that it constitute taking timely, appropriate action to changes in performance uncovered during monitor and analysis. From this KPI, we will be able to see the gaps. What was we supposed to achieve, and then what we have achieved, and then so we can see the gap. Then so these changes, performance that are uncovered during monitor analysis, so you will alert users about what are the potential problems, activities in the steps, and then guide them to how to deal with problem situations, and consequently take corrective actions, yeah, in timely manner. Okay, that is about business performance management. So how do we do? What do we do from this BPM cycle? There are in our we we need to do performance management. This is a KPI. Yeah. We need to have a performance measurement system. This performance measurement system is a system that assists managers in tracking the implementation of business strategy by comparing actual results against strategic goals and objectives. So it is a systematic comparative method to indicate progress against goals. So do you have a gap there? So the metrics for this measuring of performance is called KPI, key performance indicator. A KPI represents a strategic objective and metrics that measure performance against the goal. So it will distinguish features of KPI, distinguishing features of KPI like strategy, what are the strategy, target, ranges, encoding, time frames, and benchmark. So I put more detail in the open learning. Yeah. So for these distinguishing features, so the strategy, the KPI will embody a strategic objective, and then KPI will put up uh, performance, will measure performance against specific target. So this target will be defined in strategy, planning, and budget. So it can take different forms, for such as we can have achievement target, we have reduction target, you can have absolute target, you can create the target, and then what are the ranges that target have performance. Mainly we have some range. Okay, this is above target, this is below target, and then you have encodings. For example, colors like green, yellow, and red. There are some, for example, uh, some tools you can see that there are red flag when it is underperformance. Yeah, and then we have time frame for accomplishment of certain project, and then you have benchmark uh, or baseline. Yeah, normally, a previous year result can become a benchmark. There are two types of outcome for this KPI. One is outcome KPI. The other one is driver KPI. There are two types of KPI. Yeah, there are two types of KPI. One is outcome. The other one is driver. So the outcome KPI measure the output of past activity. So we call the lagging indicator. The driver KPI is measure activity that have a significant impact on the outcome KPI. For example, we have revenue or target profit. Target profit is an outcome KPI, but driver KPI is sales. For example, sales lead. Normally the outcome KPI is financial, but the driver KPI are more towards the value that we drive the outcome KPI. For example, production. In order to have huge larger number of sales, you need to have large number of production, and then of course you need to have large number of sales as well. So that is the outcome KPI and driver KPI. So you can put that uh, in your dashboard and so on. Any question? Okay, so this is balance scorecard. Balance scorecard is I put up a paper, the original paper by Kaplan and Norton. It is you can download it in Harvard Business Review this is in this year, 1992, yeah, from 1992. So on balance scorecard, go back to this. Okay, then is KPI. And then balance scorecard. Balance scorecard is developed by Kaplan and Norton. It is a performance measurement and management technology that translates an organization's financial, customer, internal process, and learning and growth objectives and targets into a set of actionable initiatives. This comes from the article by, yes, Ash. Any question, Ash?
This balance scorecard, right? This is similar to the balanced business plan that normally they will have in the company, right?
Yes, normally company call differently, but it's actually
Okay.
but it depends whether the company applied the exact one as per Kaplan and Norton, or they modify it.
Okay.
Okay, for Kaplan and Norton, they only look at four components, which is financial, customer, internal process, and learning and growth. So they have one financial and three non-financial. One financial, three non-financial. So that is balance scorecard. So they look into, most of the time they say measurement will be financial. Of course, everybody looking at financial, but beside financial, you need to look into customer. When if you have larger number of customer, if you can retain your customer, your business is good. And then beside customer, your internal process. If you are ineffective, inefficient in running your business processes, then your business is not good. So you need to have an efficient method of running your internal processes. But in order to be sustainable, there is learning and growth objective. So there is so this is the components. So they look into these four perspective. The financial perspective, which is the only one which is financial. The other is in non-financial. How many customer do you generate, you maintain, how do you sustain your customer? And then the internal business process perspective is how your business run. So when we talk about, I think since IMIS, we were discussing about business processes. So is your business processes effective and efficient? And then the other one is learning and growth perspective. Learning and growth perspective is how does your business sustain? Okay, I put in much more detail in my uh, yeah, so uh, the first one is the financial perspective. Oh no, this customer perspective. I put here customer perspective. The customer perspective must answer three questions. Who are our target customer? What do they expect or demand of us as an organization? What is our value proposition in serving them? So these are the questions that you need to answer pertaining to your customer perspective. So, and then there is an article by Tracy and Wisama in their book Discipline of Market Leaders that relates to these three discipline: operational excellence, product leadership, and customer intimacy. All these three is related to the customer part of this this balance scorecard. And then you need to develop metrics. Uh, you need to develop metrics. We have all this in our uh, the data is already in our data warehouse. So we will develop metrics so that we can measure them, so that we can develop histogram, we can provide dashboard and so on. So in developing metrics, customer should be analyzed in terms of what kind of customer is your target and the kind of customer we are providing. So we have your target customer, but are they the one that buying your products, and what is their expectation and so on, value proposition, maybe you, yeah. And then the only non-financial financial part of this balance scorecard is the financial perspective, only one. So it measures the performance like profitability and so on, and also risk assessment, cost benefit data into this category. We look into the bottom line. So this is the one that we look at the bottom line. And the next is the learning and growth perspective. Learning and growth perspective, uh, in order to achieve our vision, how do we sustain our ability? So we look into the enablers of this employee training, knowledge management, corporate cultural characteristic. So you have your good corporate cultural characteristic, you have knowledge management, you have employee training. So that is the essence, yeah, for this part. And then the other is internal business processes. Internal business processes is where managers should know how well their internal business processes and functions are running, whether it meet the processes, and then whether it exceeds the customer requirement. So what does it mean by balance in the balance scorecard? We need to have balance between the financial and non-financial objectives. So in balance, you need to have financial versus non-financial. We have leading and lagging. Leading is the what we refer to just now, which is the driver KPI, yeah, and lagging is the outcome KPI. And then we have internal and external, quantitative and qualitative, and short term and long term. Detail paper. There are other papers, but this is the basic paper when they were first written by Kaplan and Norton. Any questions on balance scorecard? Okay, beside balance scorecard, there is another measurement we call Six Sigma. Six Sigma actually different. It's not really business performance measurement, but it is actually looking into how to improve processes. Yeah, Six Sigma is actually how to improve processes to reduce the number of defects. Yeah, they call it defects per million opportunities. It originated from production. So, but it can be applied towards business performance because they have this DMIC performance model, DMIC performance model, a closed loop business improvement model that encompasses on the steps of defining your goal, measuring, analyzing, improving, and controlling a process. So one of it is Lean Six Sigma. It's actually combination Lean management and Six Sigma. So when you compare balance scorecard and Six Sigma, so balance scorecard is more towards strategic management system. It comes from the top. You recall it comes from the top strategic level, and then you move down towards the operational tactical level. And then, but Six Sigma is more towards the operational, where you do performance measurement system. So it balance scorecard relates to more longer term view of the business, and Six Sigma look into a snapshot of the business performance, yeah, towards how it drives towards the profitability. And then balance scorecard develop a balanced set of measure. So Six Sigma identify set of measurement that impact profitability. They look into the effect or impact that impact profitability. And then the balance scorecard measures around vision because it starts from the strategic level, vision and values. Uh, Six Sigma is more operational. It look into accountability for leadership, for wellness and profitability. And then balance scorecard look at critical management processes, how to clarify vision, strategy, communicate plans, set plans, align strategic initiatives, and enhance feedback. Whereas Six Sigma includes all business processes, management, and operational. Yes, and then there are others in terms of internal operations, target, uh, yeah. And then Six Sigma focus, balance scorecard focus on growth, whereas Six Sigma look into maximizing profitability. Yeah, heavy. So I put up this, I shared this in your WhatsApp. This note is in your WhatsApp. But anyway, it's there. It is in the open learning as well. Okay, this is Six Sigma. This is the comparison between balance scorecard and Six Sigma. Six Sigma. Okay. Okay. Any question? So, so how do
Prof,
you? Yes.
I have a question.
Yes.
Are there any preferences between industry for which performance management that they should choose? Macam for example, does manufacturing use Six Sigma more, or servicing or consulting company use balance scorecard more?
Okay. A lot of companies actually general, except for production, most production related companies use Six Sigma because a lot of them apply Six Sigma because uh, it's actually more towards production activity. But and then whereas the other industries commonly use balance scorecard. But what if we are proposing here, we can also apply balance Six Sigma to do some performance management. But only thing with Six Sigma is it is more operational related. It look into profitability, whereas a balance scorecard, we have a driver KPI and then we have an outcome KPI, and then there is this customer uh, and then your internal processes that leads towards and then your learning and growth that leads towards pushing up in order to you for you to gain your profitability. Whereas the Six Sigma actually originally originated from uh, measuring defect or measuring defects. So from measuring defects, so you will be able to measure your performance as well. So both can be used. It's up to you, it's up to your organization. But I think in service sector, we can also use Six Sigma into measuring our detailed performance of our operations. What do you think, Ash?
Because usually most companies will have the standard continuous improvement. So either it's Kaizen or Lean Six Sigma or
Mm,
TPM or
mm,
design thinking, all depending on what the organization chooses to follow.
yes,
But most importantly, it's the same uh, uh, methodology across.
yeah,
So you same language.
yeah. We can look in it as the top down or bottom up. Which one?
Yeah.
Yeah, top down will be balance scorecard, right? Top down.
Yeah.
Because
Yes.
it begins from the strategy. But Six Sigma is bottom up.
Yeah.
It can reach the same goal.
So last time when I work in Dutch Lady, we have Kaizen.
Mm.
When I work in Philip Morris, we have Lean Six Sigma. So we send people for black belt and all. So that one is more tedious lah.
More tedious. But when
Yeah.
you put but balance scorecard is actually a more balanced one that you look uh people will, you usually hear that people say balance scorecard, look at your balance scorecard, you look at balance scorecard. But these are the four components of balance scorecard that you need to look, and then the only one which is financial, the rest of the other three is non-financial. Okay, we can continue with our, okay, there are some components here which are uh, not many in the slide. I put most of it in my open learning, so we'll move into my open learning. This is the next topic, which is related to the, we're moving to data descriptive the topic is data descriptive statistic and data visualization. Yeah, we begin with the nature of data. What is data? As we have, I think previously we have talked during my MIS class that data are facts and figures analyzed and summarized for presentation and interpretation. Data doesn't have any meaning. It doesn't reflect any meaning. It's just facts, figures. You can say it is just a symbol. It can just signs. Yeah, so it doesn't have any meaning. And then but you can combine data, you can interpret data with combination with other data, so it can becomes information. So, however, data is the main ingredient for any business intelligence, data science, business analytics. We look into data. Data is the precursor, is the raw material. So, it for any decision technologies. So, whether you want to provide information, we want to provide insight, we want to have knowledge, data is the raw material. And then data can be structured or unstructured. So most of the data are unstructured actually. And then for those data which are structured, we need to structure them in order to infer some knowledge or convert it into information. We need to structure them first. That is the difficult part, especially when you deal with big data. Big data without structuring the data, you are going nowhere. Yeah, because you need to structure data. And then even people say, okay, now we can handle big data. We must remember 85% of the data are unstructured. How do you process unstructured data? Okay, you can easily say most of people that say big data are only doing data analytics, not big data analytics, because they only take the 15%. Okay, because when you look into big data, 85 to 90% are unstructured. 10 to 15% are structured. Okay, unless you are able to structure the unstructured data, so you are left with the structured data. When you process the structured data, is there any difference between the big data analytics and the the old data analytics? So there is no difference because were not able to handle the 85%. But there is, we will cover that in other topics. We have a topic on text analysis, on web mining. Yeah? So to handle the unstructured data. Okay, on when you look into data, you need to identify what is value, what is a variable. Yeah. So whenever you have a quantity of interest, something that interests you, it will take a value. And then that is called a variable. I mean a value that can be changed is called a variable. When the observation of the value, we call observation. Observation is a set of values corresponding to a set of variable. Yeah. So you have variable, we have value in that the variables, and then we have observation. Observation is the uh, corresponding set of values in the variables. So for every problem and opportunity, we look into the impact of values of the relevant variables on the business outcome. For example, we have a variable of sales. Sales is a variable. What is the value of sales? Value of sales, for example, this year we make sales 1 million. Last year we make uh, 900,000. That is the value. The variable is sales. So how does it affect the business outcome? We can assume that whenever the sales increase from 900,000 to 1 million, your profitability will increase. Yeah, so that is the business outcome. So we are concerned with the value of variable, how it can vary, and then how the variation is the difference between variable over an observation. The observation, for example, here in this case, last year the variable the value of the variable sales is 900,000. This year the value for the variable sales is 1 million. So the variation is the 1 million minus 900,000. So there is an increment of 100,000 um, sales. I, I think that is clear, right? Ash, any question, Ash?
Not really, because the thing is, like for me, because I measure learning and development data for the organization,
Hmm.
so we have the dashboards that basically processes all the raw data into the insights. Then we use that to tell the management whether we're on track or not lah, as a company.
Hmm.
But this one is a bit um, how to say, depending on what you want to measure lah.
Hmm.
Because if
Yes.
you're measuring, say, for example, training effectiveness, then you need to put down what are the definitions of it, what's the formula you're using, then it makes
Yes.
sense.
Yeah. So, but the basic of all this is data, and then these data are placed in what we call variable. So, what you want to measure is variable. So, what is in general is called variable. So, you can put anything there. It can be sales. It can be anything. Yeah. So, the role of descriptive analytics. When you talk about descriptive analytics, we begin with descriptive analytics before we move into predictive and prescriptive analytics. The role of descriptive analytics is to collect and analyze data so that we can understand the variation. What we're looking at is the variation. And then how does this variation impact the business setting? Whether increase of sales does impact the business setting. Is there a possibility that increase of sales can reduce the profitability? Yes, is it possible when there is an increase of whenever you increase your sales, your profitability goes below?
But that depends on why the sales is increased. Say, for example, you are um but hardly lah, most of the time sales go up, profit will go up lah, because
Okay,
you already set a profit margin for the product.
okay,
However, like in tobacco, we have like Marlboro is considered a money making product, but Chesterfield is not really a money making product. So
okay,
sometimes when you have the sales go up because of the promotion for that product, it's not as much. So that's the only difference. But
okay,
generally, you can assume if sales goes up, there is some profitability going.
okay. That is what we do when we do descriptive analytics. With
Mm.
descriptive analytics, we assume that we can make our inference that when sales are increasing, uh, profit should increase. But there are cases where whenever you increase sales, the profit goes down. The more you increase sales, the more profit you goes down. So you need to understand the nature of your cost. So the nature of cost. Anybody comes from accounting? Anybody comes from accounting? Yes, you're not accounting, right?
No, I'm HR.
HR. Anybody comes from accounting here? Salini, you're not accounting. You're IT. Salini.
No, Prof. I'm not from
No.
accounting.
Okay. So in accounting, okay, you are students of MBA. You should understand this because I think you also take the course of accounting and finance, right? Yeah. For accounting, we have a term we call it contribution margin. Okay, so I'll share you. I'll put up a whiteboard. Yeah. Okay, we all understand that we have this profit. Profit is actually, we call it revenue, where revenue comes from sales. You see, sales, sales. So when sales we have cost of sales. Cost of sales is the variable cost. When you minus sales, minus cost of sales, you get your what do you call it? Okay, this cost, C-O-R-S-E, this cost, no cost is called it's called costing. It is called costing. Yeah, yeah, this is called costing. When you do costing, yeah, when you do costing, sales minus cost of sales, what you get here is contribution margin. Anybody taken subject costing before? Okay, so this is called contribution margin. Contribution margin, when you minus your overhead, so you have we can call it gross operating profit. So we call it profit. It's actually gross operating profit. So when as long as the contribution margin is positive, as long as the contribution margin is positive, sales profit will increase whenever sales increase. Profit will increase whenever sales increase, subject to the contribution margin is positive. Anybody got confused? Or everybody got confused? Ash, do you get it, Ash?
Yeah, basically you need to decide that each product has a particular margin, then you know
Yes.
you got. If
Yes.
you are selling the product below market price, then you should expect a loss.
Yeah, it's not market price. We are not looking at market price.
Below your cost, sorry. Yeah.
Below your cost. This is not market
Uh,
price. We call it cost. Naveen, anything, Naveen? Any comment?
Yeah, Prof. I just wanted to share. Okay, I'm from the instrument.
Okay.
Okay. We derive sales with a mix. We have 40% of trade sales and 60% of sales. All right, and that determines our GP for the year. So what happens is, what I've seen is, when this mix is adjusted, let's say in terms of incremental of sales we have, but the mix is no more 40-60. The project sales are maybe contributing to 80%, well, contributing to only 20%. So it's a mix. Of course, we know project sales profitability is always more to trade sales profitability. So overall, we do more sales, but there are times the GPs are lower than the years before.
Yeah, because I come from the industry. I know that because whenever it's easy to see like this. Actually, when you are in the actual production, like Naveen mentioned, we have a mixture of customers, and then every customer we give different pricing. We have for example, even like a hotel, you can easily look at hotel. We have government rate, we have corporate rate, we have different kind of rate, and then even when you are doing retailing also, or you're doing production, there are customers that you give discounts and so on. So there is a mixture between your sales per unit and your cost of sales. Actually, cost of sales maintained because you're buying from from your vendor, and the production cost is maintained per unit, by unit. Cost of sales maintained by unit, but the sales per unit fluctuates. When your sales per unit fluctuates, your contribution margin fluctuates. This is why we need business intelligence. Business intelligence will be able to monitor the measurement of your contribution margin. When your contribution margin can be up and down and so on. And then your overhead most of the time will be fixed. because the overhead comprise main component of your overhead will be your salary, human resource, rental, utilities. Utilities doesn't differ much. Maybe salaries, payroll comprise a larger portion of your overhead, but your contribution margin usually fluctuate. So, business intelligence should be able to tell the management when it reach a threshold that the contribution margin becoming negative. When contribution margin becoming negative, the more you sell, the more loss you make. The more you sell, the more loss you make. It will be it might be what you call it. You might not be able to see it because if your contribution margin, even it is negative, but you might not be able to see because sometimes you don't might. There are instances that you will not be able to see your contribution margin because you have a mixture of products, So there are some other products that have been subsidizing other products. Remember, those who taken my MIS, we have a case of it's actually it is a true case. A factory in Malacca, they have a few hundred products, 100 over products that they sell, but because without any proper system, they are not able to monitor which product is making profit, which product is making loss. They run everything. So some profit-making products are subsidizing loss-making products. You only realize when you have lesser amount of sale of the profit-making product, and then you will see, you are making loss. Then how come you make loss? Usually you make profit. Just for the reduction of one product which is making used to make profit, suddenly make loss. You can see that the other product actually being subsidized by particular products. Yeah. Are you raising your hand, Ash?
No?
Okay, your hand. You
Yes,
can lower. Yeah, that's why I keep asking you because you're.
I think it's stuck. I
Yeah.
raised just now.
That's why I keep calling you because you're raising your hand.
I also don't know
Okay,
why is it.
okay, okay. Any other question pertaining to this? Okay, before we move on, okay, we move on. So I just want to understand that this is the data that we're looking at and when the role of this descriptive analytics actually to collect and analyze data so that you can understand the variation and impact on the business setting. So there are some variables. Sales are variables, cost of sales are variables. You can name it, whatever. Maybe even say payroll is a variable. Yeah, raw material utilities is a variable. And then there are some components of variable which are related to your specific industry. So the values of them, some variables are under direct control of the decision maker. Yeah, these are called decision variables. The variables that you can determine, that is decision variables. There are values of other variables that can fluctuate that are not in your control. So they can be fluctuate with uncertainty. For example, what are example variables that can fluctuate without you controlling? Yeah, anybody, Naveen? The most, especially when you did, I think the most common one. What variables fluctuate with uncertainty?
Raw material.
Yes, right.
Raw material.
Raw material can also, because why?
Because it follows the market price.
Follows the market price. I think raw material usually follows the market price due to, of course, there are some supply and demand. For example, our fuel price, and then our exchange rate, currency rate. Yeah, so these are the things that can fluctuate with uncertainty because factors outside direct control. So those are called as random variables. Yeah, random variable. We have decision variables, and we do not know for certain we call random variable. So when we look at this random variable and decision variables are things that we can control. Random variables are things that we cannot control. So there are ways that we can handle random variables. We use we use probability. Okay, and then data set. Data set is can be viewed as a set of observation. We call it data object. Yeah. So we have record, point, vector. So these are data set. Data object is described by number of variables. Yeah. So we have data object. We have data object. We have this being referred to attributes. They are called attributes. Yeah. So um, data set is actually a set of data. Data object is where you have an object, and then this object has attribute. So say you have a product. The product has an attribute. What are the attributes of the product? Is the selling price, the cost of sales, and then cost of sales have different components of it. We have material cost, we have labor cost inside the direct labor, direct material. So these are attributes, yeah, so that to capture the basic characteristic of this object. Yeah, so they have. So attributes are used to describe the data object. So attributes like cost of sales, the raw materials, or it depends on your materials. Oh, yeah. In some cases you put apportionment, so it can vary from one object to another object. So then you have a measurement scale, yeah, to associate the numerical value to the attribute. Yeah. Okay. Okay. This one. There are properties of this attribute that I think is difficult for you to understand. I think I'll give you an example. Different types of attribute. So different types of attribute. Uh, for example, there are attributes, two attributes. For example, pertaining to a staff, one is ID, the other one is age. The one is ID, the other one is age. Age you can calculate. ID you cannot calculate. ID is fixed. Although it is a number, it is fixed. The attribute is similar because it's this integer. And then age is in terms of years, so it can calculate, but you cannot mix another person's age with another person's age. So there are characteristics of certain attributes. So when you deal with attributes, these are the different types of attributes. We have distinctness, where you have equals or unequal. It's called nominal. We have order, yeah, which is we call it ordinal. We have addition, we call it interval. Multiplication, we call it ratio. There are two types of category for this attribute: qualitative category and numerical category. Numerical category is the thing that you can add and you can multiply. So this is a numerical category. Distinctive category is, for example, matrix number is a distinctive category. Yeah, it is data, it is distinctive number. For example, your IC number, your ID is a distinctive, so it is called nominal. Order is still category, but you can say good, bad, worse, or you can put ranking, grade A, grade B, grade C. Yeah, so it is by order. Okay, okay, we look into simple taxonomy of the data. Any questions before that? Everybody can follow, yeah? Okay. There are first we focus on structured data, because on unstructured data we will cover more in topic in the book. It is topic topic 5. No, topic, chapter 5. In the book, chapter 5, we will deal more of this unstructured data. But for this part, we will look into more towards the structured data first. So, yeah, structured data, there are two types, categorical and numerical. We have nominal, ordinal, interval, and ratio. Yeah, so categorical and nominal, we mentioned just now, it is distinctiveness, and an ordinal where you rank, an interval. I'll show you. Okay, categorical data comprise of labels of multiple classes. It is qualitative data. They are qualitative data. Categorical data are qualitative data. So it is sometimes we call discrete data. Yeah, meaning that it represents a finite number of values with no continuum. No continuum meaning that there is no 1.2, 1.3, 1 or 2. Yeah, so even if they are represented by numbers such as integer, they should be treated like symbols. For example, like your matrix number, yeah, so it treated as it is an integer, but yours is not integer, but there are some universities that use integer as matrix number, but it is treated as symbols. For example, our IC number, it is integers, but it is treated by symbols, not numbers. So examples of nominal data, for categorical data, there are nominal and ordinal. Nominal data contains measurement of simple codes assigned to objects as labels, which are not measurement. For example, like postcode, employee ID number, gender, if you put 1 and 2, for example, so it is a nominal data, but it is not to be measured. So operations you can do mode, entropy, contingency, correlation, chi-test, chi-square test. Yeah? And then ordinal data ordinal data contain codes assigned to objects as labeled to represent rank order. For example, hardness of mineral. Yeah, hardness of mineral, this is 1, 2, but it is not actually. Good, better, best, grade A, B, C, D, or grade 1, 2, 3. It is ordinal data or street number, route, jalan 10, jalan 10, jalan 20, for example. So it is ordinal data, but it's not supposed to be measured. So you can do median, you can do percentile, rank correlation, you can run tests, you can do sign test. The other is numerical data. Numerical data represent numeric values. So they are quantitative data. Yeah. For this categorical data are qualitative data. Numerical data are quantitative data. Yeah. So it is represented by numbers. Although some might not be numbers, but they have properties of numbers. Yeah. So for example, age, number of children, household income, travel distance, temperature. So there are two types of numerical data. We have interval data, and then we have ratio data. Interval data are variables that we measured on interval scale. For example, the most common example here is Celsius. How do you calculate Celsius? You measure the freezing point, and you measure the boiling point of water. So boiling point is 100, the freezing point is 0, and then you scale it. That is interval data. It's by scaling. Whereas the Kelvin temperature scale is actually you have an absolute zero. We call it absolute zero, and then those coming from science will know that, because absolute zero is which is equal to minus 2.72 minus 273.15 degree, where there is no kinetic energy. So other examples of interval scales are calendar dates. We have 1, 2, 3 up to, say, for January, we have up to 30th, or there are months, we have 28 months, we have 29. So these are interval scale. Yeah. Other examples for ratio data are mass, length, time, energy, electric charge. So operations that you can conduct using this interval data are mean, standard deviation, Pearson relation, T and F test. for this ratio data, you can do geometric mean, harmonic mean, percent variations, and there are other types of data which are mostly um, unstructured or semi-structured data. We have textual, multimedia data coming from image, audio, video, and we have XML. XML is extensible markup language. It is data that you can transmit from computer to computer, or JSON. JSON is JavaScript or object notation. Yeah. So data can be classified as static or dynamic. It comes in many variable types and representation schemas. So there are metrics for this data, whether we can do analytics. Yeah. We look into the data source reliability. So when you look into data, you need to determine where the data source come from. Where is the source of the data? It needs whether we refer to the originality of the data, and then storage medium where the data is obtained, and then how data have been represented. We want to eliminate or mitigate possibilities of data misrepresentation and data transformation that can cause mishandling of data when it moves from one destination to another destination. So every move data can cause unintentionally drop. There might be a missing data, especially when you do CSV, comma separated value. So comma separated value is you have comma, 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 comma. One data you do comma, one data you do a comma, one data you do a comma. And then if there are missing data in between, the other data will move in. So that's why it is best that you use XML or JSON, so you have a proper name schema for the data. And then whenever data from move to one point to another point, they might be reformatted. So it limits the integrity, and then maybe also the true accuracy of the data set. Yeah. Can everybody follow to this level? Can Ash, you can follow Ash? You still raising your hand?
Oh, I don't know why my side here is not raising anymore. I think later break time I
Okay,
will come
lower your
back.
hand.
Yeah. Okay,
Okay.
Prof.
Okay. Okay, and then data content accuracy. Besides data source reliability, when you look into reliability, you're looking at the data source. You need to be reliable. The data source needs to be reliable. And then next step is data content accuracy. So the data content must be accurate. And we did that. The data is correct, and then it match the analytics problem. So we need to do analytics. So there are data that require you to do the analytics. So it needs to be a good match, the right match, and then if you intended or defined by the original source of the data. We look into the original source, and then it is accurate based on that, and then you look into the content, and then it's meant for what is the purpose of the analytics. And then data accessibility, meaning data is readily accessible, so you can get data. So sometimes access to data can be tricky because it can be in one location, and then different storage medium, and then it needs to be merged or transformed while accessing and obtaining it. So certain portion is this side, certain portion is this side, and then you need to merge them. Data accessibility. The other is data security and data privacy. So data need to be secured so that only those people who have authority have access to it. Data richness. Data richness meaning that it can portray uh, have all the data elements included. So richness means that the variable portray a rich dimensionality. So there are, I will put in the data dimensions. It's not in the notes, but I'll put in the open learning later. data dimensions. Data consistency, meaning that data need to be accurately collected, combined and merged, and that it is consistent, meaning that from different sources, it comes from different sources, but all the sources, especially when you merge data, it is consistent. Yeah, and then data currency, data must be up to date for a given analytics model. So if you, especially for descriptive analytics, we look at past data, but not too old. Usually we look into the few years data so we can make comparison and so on. Data granularity, we look into the lowest level of detail. Yeah, granularity we refer into zooming in the lowest level of detail for the intended use of data, and data need to be validated, meaning that there is a match between the actual and expected data value. So in order to make sure that data is valid, we will put a data definition. So it need to be within the value range. And then data relevancy, data must be relevant to the study that you conduct. Okay. Uh, that is this part, and balance is in the slide. It is in topic 3 actually. I put up the notes. Yeah. So we have covered most of it in the slide. Some of the components of this slide is actually okay. This is matrix of data, simple taxonomy. This is overview. What is data? Variable, observation, variation between their decision variable and the random variable, types of data. Okay, I think would you like to take a break before we move into population, sample data, and so on?
Yeah,
Uh,
Prof.
yeah, we'll
Yes,
take a
Prof,
break for
much
a while.
needed.
I'll move into types of data, and then I will try after this whether we can. Did everybody have installed their C? No, C R. I'm not teaching C, teaching R. R. Salini, do you have R? Not yet. So I'll guide you after this. After we move into types of data, because there are
Yeah,
some
I
rules.
have, Prof.
Yes, you have, Shalini. Yeah. Okay, for
Yep.
these types of data, we will just move a little bit because there are tasks after this actually for you to do. But we'll skip that for a while until we will do this maybe next week, and then after some part of this, we will move in. We'll play with our art. Okay. Okay. We'll take a break for 20 minutes. Yeah. Okay.
Come back at 10:45 ke, Prof?
Yeah.
Betul.
Now it's 10, we take 10, 15, we take a 10, 15, 10, 25, 10, 35.
35. All right.
Yeah, 10, 35. Okay, we can continue.
Prof, can still see my hand raised.
No.
Yeah, I restarted. I think camera.
Okay. Okay. We look into this topic. Okay, we have done with the nature of data. Now we move into types of data. What are the types of data that we have? We have population and sample data. When we look into, when we want to do any analytics, we look at the population. Population is all elements of interest, and then we pick up some sample. There are several methods of sampling. Samples are subset of the population. there are different methods of sampling, but we don't cover in our topic here because once, but if you do research methodology, they will teach you how to do stratified sampling and so on. But we, for this topic, we also learn about random sampling. Random sampling is a sampling method to get the representative sample of the population data. And then, like we discussed before this, before we took the break, there are two types of data: categorical data and numerical output. Numerical data. The numerical data are quantitative data, which we can do arithmetic operations with ratio in intervals. And then categorical data, we don't do arithmetic operations on categorical data. They are distinctive data. There are two types of data which are cross-sectional and time series data. Cross-sectional data are data collected from several entities at the same time, meaning it is not over time. At the same time, you collect from several entities. Yeah. So same point of time. At the same point of time, you take at several entities or several departments or several units or several companies. That is called cross-sectional data. The other is time series data. Time series data you take from at the same point, the same entity, but you take it over several time periods. So you can look into time series data in business and economic publication. You can see previous 10 years report and so on. So graphs will help to understand the past, identify trend over time, and project future levels of the time series data. There are sources of data. We can have experimental study where the variable of interest is identified, and then you have more or two variables we identified and control. One is control, the other is manipulated. So you can see how the control should be maintained, but the manipulated data, how it influence whenever you make some changes, how you can see the differences of the outcome. Non-experimental study, which is the one that we often use for uh, social science or social study, we call it non-experimental study or observational study. Experimental study are usually used in natural science. Yeah, natural science we do experimental study, but uh, for applied science and for applied science as well as for social science, we do non-experimental study, observational study. So we make no attempt to control the variables of interest, but we do observational and surveying. Then, so how do we prepare the data? There is a process called data preparation because the data are not clean. There are many errors in the data. So we need to prepare the data before it is being before we do any analytics. There are 4 stages of the analytics processing. The first phase is the collection of data, where data is consolidated from various sources. We have looked into the metrics of data. We identified the sources of data. Data need to be accurate. Data need to be timely, and so on. And then we consolidate the data. Yeah. So this is the consolidation of data. We collect data. We select the data, and we integrate the data. Then from that, we do data cleaning or data cleansing. Sometimes we call it data scrubbing. Yeah. So impute the values. Some data are missing. We can totally remove that portion of data, or we need to find that data which is missing. Yeah. And then we need to transform data into a suitable format that is meant for our analytics processing. We need to do analytics, so the data need to be transformed first before we can analyze it or do some analysis of the data. Yeah. and then data finally, yeah, the final phase is to reduce the data, yeah, to do predictive analytics. So we have to reduce it to dimensions and so on. To reduce the dimension, reduce the value volume, and then balance the data so we can have a well-formed data. Yeah, this is uh, data reduction. How do we do data reduction? By looking at the variables, we reduce the data reduction, reduce the dimension, and then we select the variables that we want to study, because we need to look to identify the key performance. So for example, the selective aspect, selective variables. We cannot study all the data. We need to identify what variables we want to do the data, and then if we want to do sampling of the data, whether we want to do stratified sampling so that we have a balance of all format of data. So these are the data processing method. For consolidation, the popular method is we use SQL queries, structured query language queries to consolidate the data. We can use software agent. We can have web services. We can pick data from the other uh, servers using web services. We can also use domain expertise to determine which data you need to collect, access and collect. We need to select, and then SQL queries also to select the filter the data. We can do statistical tests to test to select the data, and then to integrate and unify the data, we will do SQL queries as well. SQL stands for structured query language. We call, and then you can also use domain expertise, and then you can have ontology-driven data mapping. Ontology is a classification. Is a class of categories. For example, like ontology is actually a modeling of that. It's a model, but the most common ontology is taxonomy. So it breaks data into certain ontology or taxonomy so that you can do mapping. And then so that you by this as such you can integrate and unify the data. That is how you do data consolidation. And then for data cleaning, you need to handle, there are two ways. You can handle missing values in the data. You can fill out the missing values with the most appropriate values or recode it. And then, or you can also you can identify and reduce noise in the data. You identify the outliers in the data with simple statistical technique. And then once identified, you remove the outliers of the data using binning. Binning is the bin for a range. We will cover that later for a range. And then you can also find and eliminate erroneous data. So, yeah, you identify erroneous values in data such as odd value, inconsistent class labels, odd distribution. So you can also use domain expertise to correct the values or remove records from the erroneous values. And then you need to do data transformation. Sometimes you need to normalize the data. There is a range. You normalize the data using scaling techniques. And then you can also discretize the data or aggregate the data. Data with a range, you can discretize it. Yeah, so you can aggregate them. You can have level A, B, C, or you can have a grade. Yeah, so you can have a hierarchy of the data. So, and then you can construct new attributes. Yeah, so when there are variables that you can combine, yeah, you can create new attributes, construct new attributes. That is how you can do. That's how you do data transformation. And then lastly, you need to reduce the number of attributes. You define what component that you want to analyze, and then you do maybe you can do independent component analysis, chi-square testing, yeah, correlation analysis. You can do decision tree induction. You can also reduce the number of records by doing random sampling or stratified sampling or expert knowledge-driven purposeful sampling. This is usually a qualitative method to do expert knowledge-driven purposeful sampling. Purposeful sampling is for qualitative research, qualitative method, qualitative analytics. And then you can do balance skewed data. You can oversample the less represented data to or undersample to be more represented in the classes. So okay, we will not be frequency distribution. Okay, we will cover this uh, next week. I think if we have time. Now it's 10:45. Okay, I intend. Okay. Any question on this part? Because I want to allocate some time so that you can move some introductory of R. I give you some notes. You can play around with it. We'll move. We do it step by step together. And then those with IT background it should be easy. Those without IT background, you don't have to worry. You just follow step by step. And then because I want to try to use R for data mining because next class, next topic will be more on data mining. At least we can do some simple data analysis before. Yeah. Okay. I put up some notes in your. Any question so far on the topics that we have learned today? Any question? Here from the point. Okay. And then I'll share my screen. Okay. That is my R. Okay. I have put up my R. You can just if you have installed your R, yeah, there are some base. I think I'll share my slide first. I'll share my slide. I have a slide for R. Where is it? This is an old slide I prepared in 2020 for another class. Where is it? Okay. Okay. Share. I cannot see. Okay. Yeah. This is my old slide. Okay. I introduce R first. What is R? R is actually an integrated software facility. It is for data manipulation, calculation, and graphical display. So it has an effective handling and storage facility. So it is a suite of operators for calculation of arrays, including matrices. I think we have done arrays in matrices during your school time. And then it is a large coherent collection of intermediate tools for data analysis. It is most prominent. Besides SAS, SAS is meant, if you come from corporate sector, you might be more familiar with SAS, SES. SAS is a commercial commercial product, which I try to bring as well. Actually, we'll try. There are some suite which is free. We can for academics that you can use from SAS, but R is the open source, which is widely used. So R also have graphical facilities for data analysis and display, and then it is well developed, simple, and effective programming. It's actually R originated from S. R originated from S. Previously, there was a program called S, a software, a language called S meant for statistics, and then R is an implementation of the S language. So S is a statistical programming language. R is actually derived from the name of the founder. There are two founders, which are Ross Ihaka and Robert Gentleman. So R and R. So they are from New Zealand. So In S, a statistical analysis is normally done as a series of steps, but R gives a very minimal output. So store the results in a fit object so that you can interrogate it using a further R function. So R has these 5 basic atomic objects. They have character, they have numeric, integer, complex, and logical, meaning that you can put in a character, A, B, C, D, E, or even 1, 2, 3 as a character. What we learned just now when we talk about data, it is character as character. Taken as qualitative data character. Or it can also be numeric, meaning you can calculate the number. Numeric, we have real numbers and integers. Yeah. Integers are not real numbers, meaning you have 0 0.2, 1.1, and so on. Integer 1, 2, 3, 4, 5, or a complex number, or it can be logical, true or false. So these are the 5 basic atomic classes of objects for R. So the most basic type of R is a vector. Vector can only contain, so each vector can contain one object. Yes, so it can be this object, so you have a vector. In the vector can contain only contain objects of the same class, meaning if it is character, then it is character. If it is numeric, it is numeric, integer. Yeah, if you so attributes, R can have attributes. So it's like metadata. You can point, you can give metadata to the object. So so the example of R object attributes can be name, dimension, class, or length. Yeah. So you can access using the attribute function. You type attribute, they can provide you the attribute function. So this is an example of how you can do uh, data. You can enter your input. And this is input. I think rather than looking at this, might as well you open up your R. You can have two types of suite R. The basic suite, the basic R, which is there are two types. Yeah. So this is the one. If you can install the R suite, R Studio, which is better. This is not R Studio. This is the basic R GUI. Yeah, so you can. Yeah, and everybody can follow.
Yes.
Can. So what I do, you just follow. You just open yours, and then you just follow. And then if you don't follow, you will not learn. You can just see. Okay. So whenever you have okay, the first word. The first thing, whenever people do programming, they will do hello world. Right, Rizky? The first thing when people, yeah,
Yes, that's correct.
the first thing you want to do is actually you need to do hello world. For R to do the hello world is easy. You just print. I can masukkan ni. Okay, print. Okay, print for non-computer scientists. Print is not print out into a printer. Print is actually to print back into the system. You print it out. Yeah, so you can just print something. Say you type, you put into bracket. Yeah, okay. Hello world. Close. Then when you give this instruction, this is an instruction that you give to the computer. When you send it, it print one hello world. Everybody can do it. Okay. Now you want to create an object. Yeah, you want to create a variable. You want to create a variable. We call the variable as hello world, hello string. We call the variable as we give a variable. We create a variable. This is asking asking the computer to print hello world. It will print hello world here. Now you want to assign a variable. You want to create a variable. Say we create a variable hello string. How to point to the string for it's pretty easy compared to other programs. You just use this, you just use this, becomes an arrow. It becomes an arrow. And then this is the variable name, hello string, and the content of the hello string is hello world. Say we can say hello PBS. Yeah, we can change it to hello PBS. So hello PBS is the content of hello string, and then you enter, and then you want to print hello string. No. This is small fish. Yeah, we print hello string. It is hello PBS, meaning that we have defined a variable called hello string. We give content into the hello string. So it is hello PBS. Yeah, so we declare a string. So that is a variable. You give a string. This is called a string. This is a string. String is a strand of characters. Yes, this is a string. This is a variable. You give a content, the string to the variable. When you ask to print the variable, you provide the string. Yeah. So this is the, but there are for us we can, like any other software program, like any other programming language, we can use commands. We can put in commands that it doesn't affect our type. For example, you want to do say same thing. Say we make another string. Say second string. We do a second string. Yeah, we call it second string. This is how we create our second string. We say hi MBT 7105. Yeah, this is MBT 7105. But we want to put in some comment. Yeah, we want to put in some comment that it doesn't affect the type. So what do? We can use hash, and then we type print whatever. And then we can say print. Then only we say print hello string. Second string. You will print the second string, but it doesn't affect the print text on the screen. This portion is not affected. Okay, there are several art data types for art. Yeah, for art they have vector, they have matrix. They can handle vector. This is a vector. We can have matrix. We can have a list. We can have an array. We can have data frames. We can have factors. Yeah. So first we want to create a vector. We can enter here. We can create a vector. Here. So it will not affect anything when you type create vector. But we want to create some vector. For example, we create a vector of student. How do we create vector? You just put the arrow here. When you create vector, you see you can create some names here. You can say risky. And this is a student. This the vector is called student. We have C. This is the content, the data in the student. Yeah. Then you enter. And then you want to print student. So it calls the data, Rizky, Shalini, and Ash as the vector for student. When you call print student, we have this student. And then you will need to know the class of the student. What is the class? We mentioned that there are several classes, character, integer, and so on. So there are several classes for this. This mine in my slide, in my earlier slide. So want to get the class of this. Say get the class of our vector. So we can enter and then you print. So the memory is still there. Plus the class for the student. The class is a character. So you can create other characters. Let's see. Besides using this R console, you can also use. Anybody install R Studio? Risky, you install R Studio, right? Okay. Which is easier?
Our
Of
studio
course.
is easier.
Of course, R Studio is easier. R Studio is you can do the same thing, but you can see the result in the same page. In another cushion. Yeah. So I also have installed R Studio. I have my R Studio here. So this is vector. This is a character vector. So you can use you can create vector which are numerical vector. Yeah. So for example, you can create another vector. This is a character vector. You can create a numerical vector. You can say vector 1. Yeah. So it's easy. You just put here. This is how you put in content into data into the you can put data into the vector. You can put in 1, 2, 3, 5, 3, 6, minus 2, and then you can put 4. So yeah, this is a numeric vector. You can enter, and then you want to call print vector 1. So this is a print vector 1. So you have 1, 2, 3 in there. But you want to know what is the class of this vector. You can print like you did above there. Print the class of vector 1. The class is numeric. Remember when you talk about so you can also put true, false, true, false. So there are several classes for this for the vector. It can also be so you can say you can create vector 2. How do you create the vector 2? You can put data into the vector 2. You can say put C, and then after C you can say true, RUE, false. So this is a vector 2, 2, 2, 3, 4. 2, true, false is a vector 2, and then you can print the vector. print vector 2. So this is how you print the vector code. Output is 1, and then you want to print the class of the vector. What is the class of this vector? Vector 2. It is logical. Yeah. Okay. Let's see how we can. Are the rest following me? Okay. Is everybody is everybody doing the same thing? I think this key is doing. What about Ash?
I'm
Can
still
you-
trying to install.
Still typing.
Yeah.
Okay. I'll slow down a little bit. I open up the screen. Which part? Okay. Okay. You just try. You just try whichever. You just follow. Now we know that we already have vector 1, we already have vector 2. Now how do we call the vector? How do we call the vector? Yeah, yeah. How do we call this vector? Okay, say we want to call a certain number in vector 1. Say we call it print. Yeah, we have a vector there, vector 1, and then you have this square bracket, C, and then you want to call the number, the point number 2 and 4, 2 and 4 in the vector 1, square, 2 and 4. No, this is bracket first. You must organize that. Okay, square, bracket, and then square. And then the print vector 1, yeah, C, 2 and 4. So when you start, you enter, you have 1 is 2 and 3. Why is it 2 and 3? Because 2, they want 2 and 4. 1, 2. This is 2, 4. Fourth position. 1, 2, 3, 4. Fourth position. So the second and the fourth position is 2 and 3. 2 and 3. I just stop for a while to let the other students, let you all just follow what I do. Farah, okay, Farah?
I'm still typing, Doctor. I just finished installing the software.
Okay, I leave it there first.
All right.
I'll move it a little bit up, yeah, so they can see the early part of the. Okay.
Okay, thanks, Doctor.
Okay. If you like to share your screen, anybody would like to share, just Jasmine. Let's see if I have some points. Actually, after this, you can also, there are, in my PowerPoint, there are some tasks that you can play with. Wait, I need to go back to the screen. Yeah.
Doctor, I have a question.
Are you seeing my screen? Wait, I'll stop share and then I'll open up again. I'm stuck somewhere. Okay. Okay. No Faiza, okay? No Faiza? Any problem?
I did a typo and
Yes.
then it kind of like messed up the whole thing. Do I have to redo it all again? Or...
Rizky okay kan? Rizky okay?
Hello, can you
I
hear
pun
me?
tak sure doktor kenapa. But when I try to input when I try to assign apa
The string,
the number, the vector, yeah, the
Ah.
vector, I can't seem to
Which
assign
part?
it. I don't know why.
Which part? Which
Okay.
portion are you doing?
The vector one,
Vector
then the
one.
arrow, yeah.
Okay, there is an arrow here. C bracket 1, 2. You can put any number. You close the bracket. When you print the vector, they will call the vector.
Yeah, I don't know why, but they say error object vector not found.
You can try again.
Yeah, let's try again lah.
Yeah.
Something wrong. Maybe it's something wrong when I tried to.
Yeah.
Yeah, I don't know why.
Hello, doctor, can you hear me?
Doktor, can you scroll down sampai habis?
Okay, scroll down sampai habis ya. Okay, okay, you sampai sini ya.
Yes.
This is when you call the vector, print vector 1, C in a square bracket, C to 4, meaning that we are calling the position second and position fourth. So 2 and 3, 1, 2, this is position second, fourth, 3, 4, this is position fourth. So it will call number 2 and number 3. The vector here is numeric. Numeric meaning that when you talk about vector numeric, it can be calculated. When you put it as character, it cannot be calculated. If you put numbers, but you need to have this of inverted commas so that it become character. Otherwise, it will be, for example, if you put matrix number, they will be able to calculate your matrix number. It's not treated as character. Okay, Farah, you can continue with, if you have my slide, there are things that there are examples that you can work on the slide. For example, if you want to create a vector, for example, you can create a vector by giving, by using consecutive numbers. For example, you can put it here. Yeah. You can create a vector, for example, you say A, you can create A, you can give A as 1 to 8, and then you want to check A. So it will create A as 1, 2, 3, 4, 5, 6, 7, 8. Automatically. Yeah. Or you can create B. Yeah, B as it's easy to point to the because you just use the arrow to point to the to give uh, data or number string to the you can have -2. No, you can begin with 2. So -2, we move the other way around. 2 to -2. Yeah. And then you want to look at B. B is 2, 1, 0, -1, -2. It moves the other way around. There are some examples that are available in my PowerPoint slide on the art.
Doctor,
Yes,
so meaning this program is a straightforward punya program that can be used to find the exact data lah that has been entered.
yes, and then we can also put this into a file. We can
Yes, your
create a
camera is on.
yes, Rizky.
Yes, camera is on.
Dash camera is on. Okay, we can also put up a script file, meaning that we can create all these things into a file .r. We have a file .r where you can put in some processes and then steps to do, and then it can run. But it is rather simple, right? I've done other programming. For those who have done the programming, it's quite simple compared to C or Java. Yeah.
Doctor, can we instruct to relate two of the vectors together?
Can you instruct to delete or do the vector? Can. You can remove the vector. But I'll move into that later. Yeah, so you can modify the vector. Yeah. For example, like we have the vector number A, vector A just now. Yeah, so we want to modify A, for example, yeah. Say put A, put then you put we want to modify character 1, 2, 3, number 3. Say want to character number 3. Want to character and then you want to put it this one. You want to put it becoming 1, 2, 3. You say you want to put 0 here, and then you call A again. So A, you see here 1, 2, 3. This is the third character. Yeah? A3 meaning the third character. Number 1, number 2, number 3. I change the third character to 0. So it now becomes 1, 2, 0, 4, 6, 0. You can use null and ull to delete a certain character. Yeah, so you can use null to delete the character. Okay, let's how about the rest? Still working? Which part? Farah, you have are you working on the PowerPoint? There are some examples that you can do in the PowerPoint as well.
In the nuts and bolts, ke, Doctor?
No, no, the other one, the one that I gave
R.
you at the back at the end in the later part, because
Hmm.
risky. Okay.
Yeah, there.
Nur Faiza, okay.
Yeah, I'm okay.
Okay. Anybody having problem? Said Aiman? Okay.
Okay, bro.
Okay.
So far so good, man.
So far so good. So everybody done or not finished yet? Still following. No, you have done. You can move into the PowerPoint, and then there is some examples in the PowerPoint. Today we just do the basic, and then once we move into and then we move step by step until if you can use it for some basic data analytics, data analysis. We do step
Will
by
you
step.
be also
Yes.
Will you be also teaching us regarding the shiny, Prof? Hey, Doctor.
Shiny, we can okay, we can open up Shiny, but not today lah. We will
Okay.
guide you to use Shiny. Shiny is actually when you generate Shiny, it will generate using a web interface. You will open up using a browser. You open up using a browser, so you will see the dashboard on a browser.
So shiny is a package meant for developing dashboard.
Actually Shiny is a package to develop web interface.
Oh. Okay,
To
understood.
develop web interface, not particularly dashboard, but people use it to develop dashboard because it can have a web interface. So you can open it up using a browser.
Mm.
So meaning that when you have into if you go into a browser, meaning you can do it all sort of things. It is a web application. It's like a web application. You can do all sort of things, but at the back end, it is a data analytics. Because R is meant for data analytics. It is a statistical programming language.
Okay, thank you, Doctor.
Okay.
Look forward to it.
Okay. Everybody's still working on it, eh? Actually, the first class that I do this business intelligence, I mean, at the time there was no COVID, so we do it in a lab, in a computer lab. So I can move from one table to one table. So I miss that time. So now everybody doing your own. I do not know whether you're doing or not, and whether you're doing correctly or not, because we used to do this in the lab.
Doctor, I have a
Yes,
question.
yes,
Based on the slide yang R
okay,
tu, the last
okay,
one tu, the
okay.
mixing objects, um, the tulis occasions when different classes of art objects get mixed together.
Hmm.
So why are there, even though there are the numeric and character, tapi they recognize only one?
They are because they need to be in a vector. They kena pick satu. Then any vector they only ada satu class saja. They need to have only one class. When you mix, you will just pick one.
So based on what principle they decide which one to choose?
Okay, let's see. Let's see. So when I'll share the screen. We move to the other screen for a while.
Okay.
Okay, this is what it meant here. Okay, when you have more than one vector. Okay, this is one vector. So this is character. So they assume when there is a character, the same goes like, for example, like uh, there is a ranking for R. Similar like when we do our Excel. When we do our Excel, when the first component we have some open and inverted comma, they assume the rest is a character. So when you see here, A is a character. So assume that 1.7 can be a character. So it cannot be changed. Number can be a character. And then when true and two, so they assume this is a numeric, and then true will be given as 1. Yeah? True is 1 and 2 something. And then 2 is 1. 0 is false. 0 is false, true is 1. Because 0 and 1 can also be logical. 0 and 1, false and true. And then A is a character, uh, true. So assume this is a true, and then this is a character, TRUE, instead of logical. So because this is determined by the R program. Yeah, this is determined by the R program. This is the last part. Yeah. Okay, you have done this. The rest, no Faiza? Oh, Farah.
Not yet. I baru try yang last tu.
Okay.
Try more.
Good. You try the other. Cepat je tengok, cepat je, must be must be coming from do you come from computing background?
No.
No. Okay.
But I studied lah in my diploma and degree.
Okay, diploma and degree meaning you're computing background lah.
I take business studies. So business studies can always have IT, knowledge management, all those related.
Okay, very good. So I'll go back to the other art. The other students that might be looking to still working on the previous one. We continue with the there are also some notes I shared some notes in bolts and nuts. Bolts and nuts are very basic art. Actually, for my data analysis, actually there is a book for data mining, but I'll share with you the soft copy. But you do this first, because if I share the soft copy of data mining, and then everybody got scared, and then later on. Maybe I just share with you. Yeah, it is a small, it is a example in case study, data mining. I put it up in the in this one, WhatsApp. Where is this? Okay. I'm not sure whether we have time to go through all during our course, but at least I shared some points with you, and then you can take it up in your future, in your future works. Maybe you need to do data mining, and then you have some basic art. I put it up in the Excel, in the WhatsApp. R for data mining. I need to stop for a while. Go back. Okay. You have the, you can download the book, but we will be going there later, much later. At my point, this point, you just use the art board and nuts. We will do it, play with it together. Then in the beginning, you can start with my basic PowerPoint slide. Or PowerPoint slide is very basic. And then you can move into the art board and nuts, board and nuts. And then later we will move into, after we cover the topic of that data mining, we will use the book, the soft copy book, yeah, on the art data mining. I think next week I will start using Art Studio. For this ground, we use the normal art console, the basic art console. Everybody done with this page? Whiskey done? No, no Faiza? Are you still working on this page? Done. Huh? Done. Farah is done. Shalini, you have done with this page?
Yep, done, Prof.
Done. Okay. If everybody's done, Syed Aiman done. Okay.
Yes, Doctor.
Okay. Ambiga done with this page.
Yep, doctor.
Okay. So we move on to the. There are some examples. Move on to the example in my PowerPoint slide. Move into my PowerPoint slide. Okay. Okay. These are some examples in my PowerPoint slides. This is a single object. We have covered this. Okay, this is how we enter input just now. X, we point, this is the arrow, 1, so we can print X become 1. Then you call X, X is 1. This is how you point message, hello. This is how do you do evaluation. You can use this command, yeah, giving 5 to X, print X, is explicit printing. You can put, okay, this is the range. You can put range 10 to 30. So X between 10 to 30. We have 1, we have this 10 until 30. Yeah. Okay, you can continue with this part. You can create, you can try to create vector. This one, yeah. This is doing the range, giving a range, giving the vector a range of content, a range of data. Yeah. Then you can put this, and then you can also check the class, like the one that we showed just now. Check the class from the class. This is complex, yeah. Exponential, yeah. And then this is integer. Then you can use vector function to initialize the vector. Numeric, but this 10, meaning that 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 to initiate the function, and then you can give a point just now when I showed to you. You can allocate the number. This is one you can mix the objects. Yeah, you have the PowerPoint slide with you. You can try to use, and then there is another note that I've given to you, which is the
Prof,
yes,
sorry, I just want to check. For the numerical figures, right? Does it include fractional
yes,
what do you call that? Numbers?
yes, it includes fractional numbers.
Okay.
Okay. There is another one that I shared with you. Okay, you have this with you, eh? Okay. There's another one. Bolts and nuts. Are nuts and bolts. Okay. We will do the data mining later, but at least you familiarize with yourself with this thing, the basic of R before we move into working on it. This is how you do evaluation. This is how to characters, numbers. How do you create vector? It's the same thing, explicit cohesion. And you can just and this is matrix. Matrix. You can give matrix row and column. Number of row 2, number of column 3. So we have column 3, 1, 2, 3, row, and then you can give the attribute dimension. Yeah. So matrix 1 to 6, number of row 2, number of column 3. So 1, 2, 3, 1, 2, give 1 to 6. 1, 2, 3, 4, 5, 6. You can create matrix. You can just follow in, in the notes. These are just very basic R. Yeah. You have to take a break. It's already break actually. You do it slowly. Okay, I think we take a break for about 20 minutes, and then once we come back, I will talk about it's not in my notes yet. It's not in my PowerPoint, but I will put it up in the Open Learning about the types of data sets and general characteristics of data sets. I just give out some notes, and then maybe I'll put up in my whiteboard. Okay, we'll take a break for those. You have these notes. Those who want continue can continue, and then you can continue at the end of the class until we meet again next week. We'll move into how to do some basic data analytics. Maybe we can do some arithmetics using C. But in the beginning of the class, we'll move into the other topics as well, because in the slide. Let's stop share this for a while. I'll move into the slide again. The topic 3 slide. Okay, you will be using. There are some tasks that you need to do, frequency distribution and so on. This one I will guide you using Excel. Next weekend, just using Excel, and then there are things that we discuss. And then after this, we will cover the how do you analyze distribution, and we'll cover this next week. Box plot, and then we will cover the topic of descriptive analytics. Yeah, descriptive analytics. How do you do data visualization, which is part of your assignment? We'll cover this next week. But the notes are already with you. So we'll take a break for 20 minutes. So now 50, we come back at 12:10, and then I will discuss about some types of data set and general characteristics of data sets. Okay, and then meantime, those who want to continue can continue. And then after we cover this part, next week we will continue with our R on doing arithmetic and some other things before then we move into data mining and we use it. We have the notes on data mining. Okay. Okay. Take a break for 20 minutes. Okay. Okay, we can continue. Okay, first I'll share my put up a whiteboard. Clear this first. Okay, we want to talk about the general characteristic of data. I'll put this up in the forward open learning and also general characteristic of data. Yeah. Okay, if is everyone back? Okay. Okay, we'll start with general characteristic of data. First, we look into the one is the dimensionality of the data. Dimensionality of the data. So the dimensionality of the data look at the number of attributes that the object possess. Yeah. So data with small dimensions tend to be qualitative different from those with the moderately or highly dimensionalized data. So we look into the dimensionalized of data. So what is the dimensions of data? So for example, I'll put up example in so we there are some data with principal components analysis, some data with single value decomposition, meaning that they have only single value of the dimensions, and then there are some data which have many dimensions of the data. We look into different dimensions of the data. The other one is the two is the I will put this detail in my PowerPoint and in your learning. Sparsity of data. Sparsity of data with some with asymmetric features. There are some with asymmetric features. And then there are some with zero values. So only yeah. So there are this sparsity of data, the data, the space of the data, and then number three is the resolution of the data. Data can have more broad resolution and the level of the resolution. There are levels of resolution. So resolution of data relates to granularity as well, meaning that so you look into the dimension of the data, the sparsity of the data, for this general characteristic of data sets, not particular data. When you have a group of data, so they have different dimensions. They have sparsity, the broad, the number of size of the data, number of data, and then we have resolution of the data, meaning that the granularity of the data. And then there are three types of data set. Yeah, I'll clear this up. I'll take the snapshot. Clear this up. There are three different types. We can simply organize three types of data sets. Three. One is the record data. Yeah. Example of record data, transaction data, yeah, market basket data, data matrix, sparse data matrix. Yeah, those are record data. What is market basket data? What is a market basket? Data matrix, we have data within the same attributes. And also sparse data matrix. What is a market basket data? Anybody have any idea what is a market basket data? Farah, what is market basket data, Farah?
I think it's a data about the current market and other related to it. I'm not sure.
Okay, the market basket data is good actually for when especially you are in doing marketing, you are promoting product, you need to understand market basket data. But it's simple like this. The concept is when people buy, when you see people buy grocery, when they take when if they take their market basket is the basket that they use to buy grocery items. Yeah, the analogy is they buy grocery items. The concept is like that. When they buy grocery items, they go to the market, they take a basket, and then you can see statistically, when people buy diapers, for example, they have formula milk. Do you get what I mean? When they buy diapers, baby diapers, they in the basket there are also baby formula milk. So that is market basket data, meaning they buy two things together.
Prof, is it like similar options that comes together?
Not similar options. It actually comes together, but it is not similar.
Complementary, you mean, Prof?
Complementary. Oh, yeah, complementary. Sort of complementary. That's why when you buy Amazon book from Amazon, they will say people who buy this book also buy this book. Do you notice that? People who bought this book also bought this book. That is from market basket analysis. We call it market basket analysis. Market basket analysis comes from market basket data. Market basket data meaning that when you look into the data, people who buy certain thing always buy the other thing. What else? What can you think of?
Like bread and eggs?
Bread and eggs. Okay. Well, you can see bread and eggs. You can see most of the time when people buy bread, they buy eggs or they buy butter.
Or can we say milk and cereal?
Milk and cereal. Yeah. So those are market basket data, meaning that people buy the one thing, they are going to always buy the other thing. So that is market basket data. So this is important when you sell the other product. You can say even it's not actually just grocery. You can say when you buy airline ticket, do you buy hotel?
Yes.
Right. Yeah. So people say that's why when you put Air Asia combined with hotel package, flight and hotel, that is market basket. Market basket, the name is market basket. It doesn't mean it has to be a market basket. It is a concept that you can combine two different products. And that is record data. You can get this record data from transaction data, market basket data, and so on. That is one data group. The other one is tools, is graph data set, graph-based data. The data is based on graph. What data are based on graph? Like relationship among objects. Yeah, there are two types: relationships among objects. This is when you say like ontology-driven data. Ontology-driven data, so they have a relationship among objects. For them, for example, data they have properties, they have relations, and so on. This is graph-based data. Yeah? It's not record data, but data that have relationship among objects. The other one is data with objects which are data which are graphs. Yeah? Data with objects which are graphs. Yeah. Data with object visual graph. So for example, you have here give an example like molecule link database. That is data with object visual graph. The other one is chemicals or satellite. The data itself is a graph-based data. Yeah. The number 3 is ordered data. Data comes in the form of orders, meaning that they are sequential data. Yeah. Sequence data, time series data, and spatial data. We have spatial recognition and spatial data. These are 3 types of data sets. we have discussed data cleaning and so on just now. So then data processing. Okay, that's all. Next week we'll move. I'll take this snapshot. Okay, and then I'll post this into your WhatsApp. Okay, any other question? Any question on the class that the topic that we have today? Any question on R? Okay, you can just I've given you some notes. You can play around with it. Next week we can do some matrices. We do some after we gone through with our topics, with our theories. Then you play around with some calculations with it, and then I think next week we will cover we'll cover up all topics about the descriptive analytics. How do you do your standard deviation and so on, and then we'll move into data mining. Okay, any question? How is it so far, the course? Okay.
So far, so good.
So far, so good. Yeah. Syed Aiman, okay? Amiga?
Yes, Doctor. Okay.
Okay.
Yes,
Okay.
doctor, it's okay.
Okay, Tasha, okay?
Okay, doctor.
Okay. Ash? Okay, Ash?
Okay,
Ravi
I have
Varma.
to practice on the R.
R is easy. You can ask who have done programming. R is quite easy. R is quite easy compared
Yeah, it's
to
a bit like fell like that also.
yeah, easy. Right, Rizky. What programming language do you do, Rizky?
C++, but I haven't touched a long time lah, doctor.
Yeah,
And R, I
I
have
think
actually just started learning.
yeah, I think C++ is much tougher.
Yep, definitely. I think R
Uh,
is easier compared to
uh,
other programming languages.
yeah, R can be done by any non-computer scientist. Even non-computer scientist can learn R. It's simple. Ravi, okay, Ravi Verma. My goal is actually not for you to become an expert in art because the class, this class, this business intelligence is coming from managerial perspective. But as long as you are able to understand some very basic, so you will be able to guide your staff. You are a manager. Okay, Naveen, okay?
Okay, bro.
Okay, okay. If there is no question, you can continue with your R, and then we will. I think we can adjourn early today by 20 minutes. Now 12:25. Yeah.
Doctor, question actually,
Yes.
or some sort of question. I think since art is like you need some kind of coding, so at the workplace I usually would, if I would have to be performing an analysis, I would usually use Excel or
Mm.
Microsoft base applications lah.
Mm.
So are we going to also learn analysis using Excel?
Yes. Next week we will do Excel for the some basic, from basic and basic descriptive analytics. You can do Excel. For some basic descriptive analytics, meaning that you calculating average, mode, variance, those basic analytics we can use Excel. We will then use next week because I've given you the notes. The notes that for next week actually the topic 3. You can see a lot of it is actually using Excel. Using Excel. But when you move into predictive analytics and prescriptive analytics, Excel cannot handle that. That's why we use R. And then because there is another commercial software which is widely used, which is which is SAS, SAS, SAS. So, but I'm still working with SAS to get some access of their tools. If we can get access of their tools, maybe that we can use their tools for data mining. But so yeah, so I want to have both so that you can have both. You have an open source R. You have Excel. Excel can do for descriptive, but not predictive or prescriptive. Predictive or prescriptive, Excel will not be able to do that. To do so. So Excel is good enough for descriptive. For predictive and prescriptive, you will have to use R or uh, prescriptive is a predictive using data mining. Data mining. Excel cannot do data mining. And SAS, but I'm not sure whether we are in time to get because I'm in communication with SAS to get some tools so you can use. Okay. Have you heard of SAS? SAS. The site is sas.com. SAS.com. I'll type in the message. Okay, it is a commercial tool used by corporate sector. Usually large organizations use SAS. Okay. Banks, large organizations. Okay, any other question? There are tools actually. We can let me share some. Let me say we have some time. I'll go to my communication. Okay, I'll share my screen, yeah, for a while. You're still in time. Still have time. Okay, this is SAS. This is SAS academic program. So it's actually a low cost option. I'm not sure how much low cost it is because they are in US dollars. So there are SAS University Edition that you can use some of these technologies, and then there are webinars, e-learning here. Let's see if we can do this. So there are software that you can use. This is some free access software. I'm trying to get access to these software for the class, but I'm not sure whether I am in time to get. Otherwise, we will just use R, because SAS is more towards the commercial sector. It is not open source. It is not cheap anyway. But if you work in a large organization, and if you're planning to work in large organization, so it's good for you to have yourself exposed. Yeah. So you can explore yourself SAS. So this is SAS Studio. How to learn basic SAS. I'll try to get SAS for your data mining. Yeah, this is SAS Studio. You can request demo to do your analytics here. Yeah. Then we have the video tutorial. This is the pricing. Yeah, it requires some codes. Yeah, there are few trials. I have to check whether we can use them or not. Otherwise, we will use R. R is actually widely used. R is also widely used because it is open source. R is open source. S is not open source. S is you have to pay. Okay. SAS is open. It's not. You have to pay SAS. Okay. Any question? Any other question? Risky, okay? But for descriptive, like
Okay, thank you, Doctor.
Excel is okay. Yes. Risky?
Oh no, thank you for answering my question just now.
Okay. Okay. Sally? Hanif, okay, Hanif?
Actually, Prof, today was like very heavy. It needs a lot of practice. Maybe I'll watch this video 2-3 times again.
Okay, you try. It requires practice. Actually, it's not that difficult. It's easy. Yeah. Okay. If there's nothing, it's now 12:33. We are a little bit early, but we can adjourn for today until we meet again. I think we have class again next week, right? Okay. Okay. See you. Bye. Assalamualaikum.
Thank you, Doctor.
Thank you.
Waalaikumsalam.
Thank you, Doctor.
Uh,
Thank you, Doctor.
Thank you.
Bye.